All right, good morning. It is 11:15, so we will go ahead and get started. Welcome to the architectural engineering session, and my name is Sari Bailey. I'm associate professor of architecture here at HAC, and I'd like to introduce Josh Zilbaugh, who is a registered architect with Gannett Fleming, and he will be our presenter for the day.
Thanks, Sari. I hope everybody can hear me well. I will share my screen here. Let's come up to the... All right, so as Sari said, yes, I am a registered architect. I work with Gannett Fleming, which is a large engineering firm located in Central PA, headquartered in Central PA, but we're all over the world. But yeah, I am a principal architect with Gannett Fleming, and am a regional manager. I manage the Pennsylvania practice, and I also am an adjunct professor at HAC, and teach the construction materials and methods course. So probably the driest course there is to teach, but I enjoy it a lot, and I think the students enjoy it a lot as well. But there's more to dry stuff than to architecture. So hopefully I will, expand a little bit of thoughts of what architecture is for those of you that are watching and are interested in considering a career in this path. So I'd love to find a way to get this off of my screen. I don't know if everybody can see that or not. Anyway, the way I like to break down this presentation is three parts: the work and the path and the prep. This is admittedly, my presentation is a little bit outdated. I need to update some things in it, but the general idea of things is still correct, and I'll make sure to note what has been updated or changed a little bit from when I first put this together more than a decade ago. So it's well past due me having to update this, but I do think it provides a good overall understanding of what architecture is. So the first part of what the work is, there's a lot of misconceptions, I think, from younger folks and even people in the working world ancillary to architecture who kind of feel they understand what architecture is or what an architect does, but really don't fully get it. I always love this image of the Kohler architect stereotype. It was a commercial from way a long time ago. A couple brought in a faucet they loved from Kohler and sat it down in front of this guy in a black turtleneck sitting in a stark, terribly uncomfortable looking room with no padding, just concrete and steel and glass, and say, design me a house around this faucet. And it's this idea of this individual who just kind of has these strokes of genius that come to them about how to put a space together. And it's not really like that at all. There is so much that goes into what architecture is, and all of the working with other disciplines and engineers, and being able to communicate clearly with clients and with contractors, and again with other engineers and other professionals inside the design community. What does the word itself mean, though? So architect really means chief builder. So it's this term that means it's an expert in the design and construction of the built environment. And one of the things I want to impress upon you is that the built environment can be more than just a building. It can be spaces of different types, exterior spaces, just interiors. These are all part of the built environment that we inhabit and live in every day. But it has a lot of, it encompasses a lot of different things. And I always like, when we're doing this in person, it's always easier because we're sitting in a classroom and I can say, look at this room. But just asking you wherever you're sitting right now to look around. Most of you are probably sitting in your homes, or you might be in a school setting or something like that. But if you look around the room you're in, there were literally hundreds, if not thousands, of decisions, little decisions, big decisions that went into the room you're sitting in. Somebody had to make those decisions. They don't just happen. And a lot of times it's an architect, a lot of times it's an engineer, a lot of times it's a contractor, or it's a combination of all three. But the point is that these decisions have to be made, and there has to be an understanding behind them. there has to be a science behind them. But in architecture, there's also an art that comes behind it as well. Some of these images I put on the screen here, the image on the top, the London City Hall, this was designed by Sir Norman Foster, who is one of those architects. He's an architect, but he also does engineering. He kind of transcends that line between engineering and architecture. And this building sits directly across from, I think, the Millennium Bridge, but sits right along the river in London. And the building is not designed the way that the shape that it is not arbitrary. It is designed because of the strong winds that come off of the water and actually hit the building head on. If this building were designed as a traditional rectangular shape, it would actually be more expensive to build, or the theory going that it would have been more expensive to build than what you see here, because by using structural modeling and modeling of the wind forces that come across the building and the way that the building absorbs those forces and wraps it around the building, the steel was designed extremely efficiently. All of the structure, all the way down to the foundation, was as efficient as it possibly could. So the material cost was less, significantly less, than it would have been if this were a big rectangular building with a broad face. So it isn't an arbitrary thing. There's a beautiful art to this building, but there's also a science and a reason behind it. The pictures in the middle, again, getting to this idea, and the picture at the bottom, the same thing, but getting to this idea of architecture is more than just a building. Those two pictures in the middle were designed by the same person. So I hope many of you have been down to DC or seen the Vietnam War Memorial, but this was a student competition. This was a project that was designed and completed from an architectural student, and the same architect, who she's now a practicing architect, works on multiple buildings and homes, and that house that you see next to it is a project that she designed. But the Vietnam War Memorial is a beautiful example of the built environment and the way that architecture can impact space more than just a building. And it's the same thing goes for the Piazza di San Pietro in Rome. When you look at the building, it's really about the space that isn't there, or the courtyard, or the void where the structure isn't. That is what Michelangelo and the architects of the day were trying to get across. I'd like to talk a little bit about macro and micro design, that understanding architecture can be more than just, again, this notion of it being just a building. The top image was the redesign for Paris by Baron Eugene Haussmann in, I don't know, the 1600s, the 1500s, a long time ago. But the idea was this architect who did buildings, who did designs and put structures up, redesigned the entire layout for Paris, which became the basis for how that city was redesigned. This is a macro level design. There are many architects in the past who have written about city layouts and design, the way that cities are put together. And it's something that is on a very large scale. By comparison to that, the bottom image comes from the Jewish Museum in Berlin, which was designed by Daniel Libeskind. And the building, I'd love to pull up an image of it. And when I read you these slides, I need to show a plan. But the building is kind of shaped almost like a lightning bolt. It just kind of zigzags all over the place. But it has this atrium that runs kind of as a straight line that dissects all of the building and runs all the way from the roof down to this subfloor level. And at this lower floor in that atrium is where you see these discs that I have a close-up image of. Daniel Libeskind designed this art installation to his own building. And these discs are, maybe 3, 4, 5 inches across in diameter. But it's a space that you can actually, as part of your museum experience, you can go out and walk on top of them. And this is a Holocaust museum. So there's a very specific statement that's being made by Daniel Libeskind in this. And it's a very intimate and a very sacred space in a lot of ways. But the idea of just these little discs that are a few inches across is architecture, just the same as redesigning an entire city is architecture, because it impacts the way that we experience space, inhabit space. The text on the slide talking about architect as project manager. So we talked a little bit about these more theoretical things and these heady things, but the day-to-day stuff for what an architect does. An architect in most cases serves as a project manager. So that means they have to be the expert in architecture, but they have to understand all of the different trades that go into a building or into the space that you're designing: structural, mechanical, civil. You see the list there. Going back 150 years, there was no trade or profession called an engineer. There was only architects that did everything for a building. But because the complexity of buildings has ballooned and exploded in the last 150 years with all of the systems that we have, there is so much understanding and science that goes into putting structures and buildings and spaces together that one person cannot be an expert in all of it. So we have all of these different disciplines, but there still has to be somebody in every case who has to herd the cats, so to speak, right? Or bring the team together, communicate everything together as a group, and take all of those ideas, make sure that they're coordinated, and make sure everybody's moving in the same direction, and take that information to a client, communicate it to a client or a user, and take their information back to all of the designers and the design team. And in most cases, not every case, but in most cases, that person is an architect. They are the project leader, the project manager, the face to the client who is running the project and making sure that everything is being done to get the space or the design or the project to where the client or the user needs it to be. Architects do construction drawings. So I like to use this old barn design that we did many years ago as an image, because this is a simple 3-room building, but you can see just in the way that these drawings are presented, there's still so much information that has to go into putting a drawing together, a design drawing that can be built. These are, again, we're talking about some metal siding on a pole building with some masonry, and you can see the level of detail that has to go into all of the notes and all of the annotations and all of the call outs and all of the dimensions. Drawings typically, and this isn't a universal thing, but they typically show the quantitative aspects of a project. So all of the sizes, the lengths, the dimensions, the amounts. And then the flip side of this is specifications. Architects have to put specifications together, which are usually, and again, not universally, but in most cases, the qualitative aspects of a project. So the drawing may call out masonry on a wall, and that's all it will say. It'll give dimensions and say masonry, but the spec will tell you exactly what type of masonry it's to be. If it's a certain weathering type, or if it's to be made of a certain color or have a certain composition of materials, all of that stuff, you can't put all of that information on a drawing. So some of the information has to go into a specification, which is what architects also have to be responsible to put together, and engineers as well. But I won't bore you with talking about specs too much, because it's literally written out text like this. The job of the designer, the architect, does not end when the project is designed and out the door and being built. We have to be there and present during the construction phase to ensure that the project is being built according to the drawings. And this is through a lot of different means. There's ways that we deliver projects, and I won't get into the nitty-gritty details, but the traditional design bid build. We design it, it goes out for bid from a contractor, and then it gets built. Or you're working through the design when you're teamed with a contractor in what's called design build. And the contractor has input in the design, and you're working on that together all the way through the design and construction phase. But in both cases, the point is the architect is there through construction. They're reviewing submittals. They're making visits to the site to observe what's going on and make sure that everything is being done correctly. And in some cases, as that last point shows, architects can become construction managers. They can make a career out of simply managing construction. There are many architects who do that and don't really do design. So this is one of the slides where some information is outdated. I put the slide together, 10 years ago, so the numbers are old. But the point is that this is a regular profession. It can be, you can work in a firm where you can work 40 hours a week and not do a lot of overtime, or you can work in a firm where you can do a lot of overtime and be expected to do a lot of extra work and overtime. But one of the keys I like to make the point of is not a private profession, right? This is not a profession where you just go and sit at your desk and do your work and kind of have the blinders up and that's all you do. There are people who can work that way, and architects or designers who may make a career doing that. But for the most part, this is not a private profession. We are we need to be good communicators. We need to be able to go and present topics and information and explain it clearly so that people can understand it. We did a large church project many years ago, pretty early on in my career, and I went out and did presentations in front of 1,500 people with designs, concept designs, and images for a building that they were very emotionally invested in, and had to explain that stuff very clearly to them in a way that they could understand it and then respond with questions and discussion. And it was really a great experience. You can be afraid to speak in public. You can be afraid to do those things and still become an architect and do that. But it's a skill that is something that you can learn. So that's talking about the work. So I want to talk a little bit about the path. I'm trying to make sure I keep on target here so we have time for questions and discussion at the end. So again, this is another slide that's outdated. I need to update the way that things are worded. But there's a general path to how you become an architect. And it is a long road. It's a difficult road. Actually, Sari was just saying this the other night when we had a meeting for curriculum and for career support and things like that with Hack. It is a difficult path. It's one that takes many years to accomplish. And there's a reason for that. When you are licensed as an architect or you are licensed as an engineer, there is an aspect of public safety, of the welfare and well-being of people that is put upon you, that's put upon your seal that you're putting on a drawing. I mean, we've all, of course, I think heard in the last year, right, the partial collapse of the building in Miami, bridge collapse in Pittsburgh recently. There's all kinds of things that occur where things can fail. Things can, for a lot of different reasons. And the engineer, the architect that is responsible to do design has to be sure that they are doing what is required by the code and what is correct. For the architect, that mostly comes down to life safety and fire safety for a building, to make sure that people can get out of a building in the event of an emergency, that they can get out in a timely manner, in a safe manner, that there's sufficient space and sufficient exits and the lengths and times to get out of a building. It's not just about putting a beautiful design together. It has to be a beautiful and safe design and correct design per the building code and per the requirements of the law. So that's, again, why things are so stringent, why it is a long road, why it's a difficult road. But there are three main steps that you have to do to become an architect. You have to, one, in this first slide, is to obtain a professional degree from an NAAB accredited school. That can be through a lot of different means. And I need to update this slide, but you can do a 5-year Bachelor of Architecture degree, 5 years minimum, get the architecture degree, and you have it and you're out. You can go and get a master's degree, an M.Arch, which is the same degree. It's still a professional degree, and you can start by having a pre-professional degree in architecture or even a degree in something else and go and get that Master of Architecture degree. You can start. I have people that work in my group that went to Hack and got a architecture degree there and then transferred their credits to a school like Drexel or another place and came out with a professional degree, and they're great employees. So there's a lot of different ways that you can do this, but the key is you have to eventually get that accredited degree from an accredited school. And the schools are limited. In Pennsylvania, I believe there's only 5 schools that are NAAB accredited. Pitt, as it is always an example I like to bring up, they have an architecture program at Pitt, but it is not an accredited program. If you get a degree there, you don't have an NAAB accredited degree that will allow you to become licensed. You can do also what I did, and I have my little diagram there of the schools I went to, but you can do what's called a 4+2, where you do a pre-professional degree in architecture, you receive a Bachelor of Science in Architecture, which I have, but it is not a professional degree. I had to go and get a master's degree, which is like that M.Arch listed above. The difference was I had less years to complete it because I had the 4-year degree from my undergrad. So once you have the degree, you have to go through what's actually now called the AXP. So this is an outdated slide. I apologize again for that. It used to be called the IDP, the Intern Development Program, but it's the AXP, the Architect Experience Program, I think is what it's called. But all of it is essentially the same thing. It is a period of multiple years where you are working full-time or part-time under the supervision of a licensed architect who is making sure that you are getting experience and time and hours doing a whole bunch of different things that encompass the profession. So you can see this little cutout here. And again, the numbers are a little bit different now. This is actually a screenshot from my IDP when I finished it. And you can see this number, 7,706 and 3/4 approved, 0 remaining. That is hours. That is how many hours it took me to complete this process, because you have to get experience in all of these different fields. You can see what they are, and they are a little bit different now the way that it's worded, but you can look this up through NCARB's website, NCARB, and you can see what it is. It's free to you to go and look around that website and see what's listed there. And you can get a lot of information that will break down how this works. But essentially, it's a period of years where you get training. And you are signed off by an architect saying, yes, so-and-so has done this work. I supervise them doing it, approving those hours, and you have to log it and complete it. I'm doing this for 3 individuals right now, where I'm logging and tracking what they're doing and confirming, yes, this person has done the work and did this many hours doing it. The third and final step is the ARE, the Architect's Registration Exam. Again, a little outdated here. When I took it, it was a 7-part exam. And that's really kind of a tall tale. It's really 7 exams because they're all multiple hours long. It is actually 6 parts now. It's a little bit less, but I think pretty much the totals are the same: 33.5 hours, 555 multiple choice questions, 11 drawing exam questions. It is a bear to complete. It takes a long time, a lot of effort, a lot of study. But again, getting back to what I said at the beginning, there is an aspect of public safety, of health and wellness for people that architects are charged with. And this is extremely important. So the last point about these slides, this path section, is there are these 3 parts, but they don't have to happen in successive steps. You have to have all 3 of them to get a license. Once you have the accredited degree, once you complete the AXP and the experience, and once you pass all parts of the exam, you will get a license. You will be a licensed architect. But you can be working on your AXP while you're going through school. If you're working internships or part-time or whatever it may be, you can continue to do that. You can complete parts of the exam or even finish all parts of it before you finish the AXP. And then once you finish the AXP, you would get licensed. You don't have to look at it as a lineal progression through these steps. So the prep, the last part of this, what are some things you should know right now if you really are considering a career in this field? Architecture school is not easy, but it's wonderful. Those of us that have gone through architecture school would probably agree to this. It is an experience unlike any other. This image, I love this image. It is from, I'm pretty sure it's from Virginia Tech, but when I took it, years ago, it just shows the beauty of what I always think of when I think of Architecture Studio. And there's a lot of things in this image I want you to kind of see. One, you see the messiness of it. You see the amount of scratch paper and trace paper that's being used as students are going over the designs multiple times over. You can see pieces of models that are being built and used. You can see all of the different markers and the coloring tools, the books to reference. But one of the things I love about it, and I hope you can see, is that there are no walls up between the desks. There's no blinders up. This is an education. Architecture school is an education that is built upon you going through a design process, learning how to design with your peers. You take the work that you're doing, you pin it on a wall, and you talk about it, and you learn about where it could be better. You get that criticism, constructive criticism, not put you down criticism, but criticism that says, hey, this is really good. This really works for the problem or the problem of the project or the design, but there's a lot of things that need to be worked on over here. And that is how you grow and how you develop and learn and improve. And that is the design process, the iterative process of architecture school. And this continues as you're in a profession. I, yesterday for work, presented to our entire architectural practice at Gannett Fleming, 50, 60 persons, a project that I was a manager of that had a lot of errors and a lot of issues. And we said, here's the things that went wrong, and here's what we learned, and how we can do better, and how we can improve our processes. That criticism, that growth that comes with you through your career is something you need to embrace and take and use as a learning tool. And architecture school brings that out and brings it to the forefront. And it's a wonderful experience. I went to Maryland with 51 other students. We went through the studios together and graduated together. I knew all of them, all 51 of them. I knew them by name. We were there in studio together during late nights and during charrettes and sleepless nights when you're finishing projects for a review. It's a wonderful thing. It's almost like a built-in fraternity or sorority that you have, when you're in college. It's great. And in Syracuse, even more, there was 12 of us. So, I mean, we knew each other's families. We knew, some were married, some were not, we knew everything that was going on. We spent so much time together, and it's a wonderful experience to go through, and you're learning with them. So you see the mistakes they're making, or the successes that they're having, and you're able to take that and say, wow, that's a great solution to that. And I can use that, and I can grow with that as well. And like I said, it's not done in a bubble. You put your work up on a wall, and people look at it and they review it. These images I took from my own thesis at Syracuse. All the stuff I had there, all of the models I built, and this is the view from where you are when you're presenting. You stand there, and there's professionals who sit in these chairs, and they sit and they talk about all the things you did wrong. But it's great constructive criticism that you can learn how to do it better the next time. And lastly, I like to say architecture is worth it. It's a wonderful profession. This is that church I was mentioning earlier that we did years ago. It was a wonderful project to be able to work on and be able to see it come to fruition and see a space that people use and enjoy. And I enjoy what I do every day. I look forward to work. It's wonderful. And those of you that are considering it, I would certainly recommend it to you to continue to push and pursue it. Some additional things: drawing, sketching. You don't have to be some great artist to be an architect. I knew so many students, and myself included, who really could not draw much at all, but it's a learned skill. You can learn to sketch. You can learn to draw. It's not something that you just have to have innately in you to do. Thinking in 3 dimensions rather than 2 dimensions. That's something that comes with experience and time. But there are tools out there that you can download, free versions of what's called SketchUp or simple design tools that you can build something in 3 dimensions as opposed to only thinking in plan or 2 dimensions. BIM, if you have that option in classes in high school or pre-college classes to learn what BIM and Revit is, to build a model in design space, thinking in that kind of mentality as opposed to the 2-dimensional thinking. But the big one in the middle: learn to listen to and accept criticism as a valuable learning tool. That is extremely critical for growth in any profession, really, but it becomes paramount in architecture because that's part of that iterative process. And that last image at the bottom: learn to expand your horizons and understand that there are many things that are possible. That image in the bottom there, it was a rendering when I put this in the slide, but that is an actual project that was built by the OMA, by the Office of Metropolitan Architecture, which is Rem Koolhaas's architecture firm. I think he's an office in New York and in Paris, but that building was really built. And we could have discussions on if it was a waste of expenses and money to do something like that, or what the purposes were for it. But the point is that a project like that, of that kind of building, with that kind of a cantilever and that kind of a shape, was actually built and is doable. I have some last answers and questions up here as we go into questions. I think it's right around 11:45, so I talked for about a half hour, and I hope that there are questions. And again, some of these are a little outdated. I've tried to update some of them, like in terms of the salary stuff. That stuff always changes and flows with economy, but in general, architecture is a moderately well-paid profession. You're not going to go into architecture and become a millionaire, but you're not doing it to do that. You're not doing it to come out with that kind of takeaway from your career. So I guess now I'll take questions. We'll have a discussion, and you can read some of these. So thank you.
If there are any questions, you can type in the Q&A.
Q&A is different.
Okay, so there is a question. Do you think that architecture is influenced by culture?
Absolutely, it is. There is a component of architecture that is theoretical based, and when you hear words like classicism, postmodernism, even modernism, these are terms that are used to define the way societies think, the way societies act, cultures interact and think, and architecture is representative of those things. When you take architecture history courses or go through the history of how architecture works, the culture has had great influences on it in terms of buildings that were designed for public space and discourse, which was something that wasn't really available for societies for a long, long time. Architecture had an influence in that. And it isn't just a responsive influence. It can be an impactful influence as well, that architects can in some ways help solicit and bring upon needed changes in the way that things are designed and spaces are put together, because it influences and impacts the way that people communicate and interact. But absolutely, yes, it very much so. How do you build a structure to withstand earthquakes? Oh, okay, well, I am not licensed in California or Washington or Hawaii. I'm trying to think of, I was actually saying these to my wife the other day, what some of the states are that require an extra test. There's an extra exam to be licensed in those states that is a much more rigorous exam on seismic design. But there's a lot of things that actually are covered in the class I teach as well for HACC that talk about these things. But it really has to come down to the way that the structure is designed, which is primarily led by a structural engineer, and not only just the building structure itself, but the foundation of the building. Because where seismic events occur are in the ground, and they come from all angles. It's lateral and direct, and from below, and even being pulled down. So earthquakes are very, very dangerous in that regard, because they put so much pressure on a building from all angles. But there are all kinds of designs that go into the foundation. There are foundations that absorb seismic events to limit the transfer up to the building. There are buildings, the way that frames are designed, and the code requires a certain level of this, that they have what are called, I think it's called dog bone frames, and these different things where essentially parts of the frame will fail. They absorb all the earthquake loads and will fracture, which sounds like a bad thing, but it's actually, they fracture and absorb all of the stress so that the rest of the building doesn't get it. It's like a sacrificial thing. So there's all kinds of things that go into the way buildings are designed to absorb them. And I think this is another thing too, where we've seen issues and we've grown and we've learned. When you look back at the 80s and some of the massive earthquakes that occurred and buildings that collapsed, the requirements have changed in terms of what the minimums are to design to, so that when big earthquakes happen, we have buildings that can reasonably withstand them. And will, again, the purpose being that it's not really about saving the building. That's important, but the key is about saving lives and getting people to be able to be safe and to get out of the building in an emergency. How would you pressurize a structure for, say, underwater living? uh, that's an interesting question. I've never considered something like that. You know, it would be theoretical at this point, but I would say that there are portions of buildings, there are parts of museums, and obviously aquariums and things like that, where large portions of structures are constantly under water pressure. But there are several things that come into play there. Water isn't just about the building being watertight, but all of the pressure that pushes upon a building, the hydrostatic pressure that water pushes upon it. That stuff over time can be it, over time it will begin to show wear, and buildings over time they don't, I want to say they fail, but they begin to deteriorate. So there's a lot of ongoing questions that come when you're thinking about doing something underwater. But it's something that I've not put a whole lot of thought into, other than what we understand now in terms of how we have to resist water pressure in soil and things like that. But very interesting question. I don't have a whole lot to give you on that, unfortunately. Strongest building material that you know of? Well, I mean, there's obviously other professionals here, but it's in terms of common building materials, there's few things that have given us the advancement that steel has given us. Steel's an amazing material that has amazing strength, but also very significant flexibility and what's the term? Resiliency. So it can absorb stresses and return back to its original shape. That's this idea of resiliency, right? So I always loved a presentation when I was in school about a rubber band. A professor in a structures class took a rubber band and stretched it and showed us how it works, and then showed us the strength curves. And I'm not going to get into the details of that, but it's really amazing that rubber has a very similar strength curve to steel. And the point that this professor was trying to make was that steel has a lot of resiliency and ability to change its shape and return back before it's overstressed to the point of failure. So when steel originally comes from iron, right? It's an alloy of iron. Iron by itself can be very brittle, or it can be extremely flexible, so to the point where it will fail quickly. But when you add different materials different metals into it to make it steel, it becomes an amazingly efficient material to build from. And there are certain little things that draw back to that, but I would say steel. I mean, there's obviously amazing new things out there, in terms of certain finishes and polycarbonates and things like that are high strength and thin and lightweight. But in terms of real building materials that you build large structures or spaces from, steel to me is but then at the same time, you have something like concrete, which is pretty amazing in and of itself as well. So, but yeah, I think my money would be on steel. Take advantage of the landscape while building. Well, absolutely. So this gets into what was discussed too about all-encompassing designs, right? So there are landscape architects who design landscapes, civil engineers who design the site of a building. There's an aspect of this that the architect has to be able to coordinate with those people, with those professionals and what they're doing. But the building itself can and should take cues from the site that it's on. The building should never be looked at. And again, I talk a lot about buildings. I made the point early in the presentation that's more than just buildings. Architects can design sites. I've designed multiple exterior spaces that really have to do with landscape and the experience of the exterior space. But in terms of talking again about a building, an architect should never look at a building as being just kind of designed in a big white space, like we do in Revit or something. you have to do it in that way when you're putting drawings together in a model, but you have to think of it in terms of its relation to a site. Visual cues, the ability for the building to get sufficient sunlight, to penetrate windows, depending on what the needs are for the inhabitants, or to keep light out, right? I mean, there's all kinds of things that go into it. How much of that is absorbing too much heat in the summer, allowing sufficient sunlight in the winter, prevailing winds. I talked about that building in London, the London City Hall by Sir Norman Foster. I mean, the site, the landscape of that building had a great influence and impact on the way the building was designed. Absolutely. You take inspiration from natural formations. Well, certain architects will, for sure. It is, I always think of Frank Lloyd Wright did a lot of that. He was a modernist with some little tweaks to that, but if any of you have been out to Fallingwater or seen that building, I mean, it certainly takes cues from the nature of flowing water downhill and waterfalls. But there are architects who will do that more than others. And again, this gets back to that theory question. There would be some architects or professional designers who would say that, a building should represent classical scales and not really kind of speak directly to natural formations and the natural landscape or things like that. And architects who would say that the building should flow out of those things more naturally. And these are not necessarily conflicting things, but there's different schools of thought or different approaches to how design should be done. But absolutely, there are architects who do that. Very good question.
Are there any other questions? Well, all right, Josh, thank you so much for being here with us today. And that was truly a fantastic overview and great. I believe you answered all of our guest questions. So thank you again.
Thank you all. Appreciate it. And best wishes to everybody moving forward as they consider a career.